Okay, very big welcome to Pennine Ham this evening and to the second of our meetings this month. Really pleased to have Frank Kilo 4 Foxtrot Mike Hotel K4FMH come back to the club. Those that have been with us a while will remember Frank has given a number of talks to us, the most recent, of course, on the solar cycle 25 and issues about propagation in the current solar cycle. But Frank's given quite a few talks to us over the years, both at Pennine Ham and when a number of us were in another local club up here, Denby Dale. Tonight's meeting is going to be about a subject which I know is dear to the heart of many people in the room here tonight, but also to many people who will be watching this on the video that is published on YouTube after the event that will go up there tomorrow. For people who weren't able to get here tonight. We've got a lot of members who are very much enjoying portable operations, enjoying the going outside when the weather's decent. We're not quite there yet up here in the north of England, or even in the south, I don't think. Just for a day maybe, and then suddenly, as we've had today, torrential rain. So at the moment, we're still at the dreaming stage of working portable, really, unless you're doing it from your car. I'm one of those that likes to go out with a backpack and radio on that and wander up into the hills that way. And that definitely needs decent weather. So when Frank told me some time ago that, in fact, I think the last time you were with us, Frank, that you've been writing a series of articles and thinking while you were resting up after an operation about things you could do outside, what kind of portable antennas would you use? And I know you got Practical Wireless accepting them for publication, and a number of them have appeared in Practical Wireless over the past few months on some of the designs that you've come up with. So when I spoke to you recently, I suggested to Frank this would be a good time to come, and Frank said just about one of the antennas or the whole suite. And I said let's have the whole suite. We just give us an introduction. And I'm sure between us in the room here, we can find ways of enabling you to see the articles that Frank's published in Practical Wireless. So, Frank, that's my introduction. I'm then just going to hand the microphone over to you and let you take it away.
Well, thank you very much, Nick. And it's truly an honor to be asked back again. I think at the end of the day, I sometimes joke at the end of the week because I'm a long-term thinker. Time is our most precious commodity. And so for you to choose to spend your time listening to me talk about something I'm interested in or think is important is truly an honor. I'm going to start my slideshow. Nick, coach me. Are you seeing the full slide?
Yeah, we are. Yep.
Okay, good. Then, and you're hearing my audio okay?
Yeah, absolutely fine.
Okay, I can't do anything about the picture. I will give one explanation. If you see some dark spots, I'm undergoing a fluorosil treatment from a dermatologist. As we get to a certain age, we tend to be subject to melanoma and things like that. And my dermatologist has had me apply this cream called fluorosil. And it will make sun-damaged skin show up, and she'll come check it and stuff. So, no, I have not been to the zombie apocalypse party and returned to give you a talk. That's just where I am. As Nick mentioned, I had prostate cancer a little over a year and a half ago, almost 2 years, and I went to the Mayo Clinic in Minnesota and had surgery. And when I was recuperating up there for about 10 days, with all the things they have you hooked to and all that, your mind wanders. And I've been enjoying antennas since I was 8 years old. I had the famous transistor radio when I was 8 for a birthday present with the whip antenna. And my older and bigger and much meaner brother stepped on it and broke it. So what could I do? I cried a bit, I remember. Was sort of heartbroken. Here, my new birthday present. I couldn't hear anything, but somehow at night I put my index finger on the nub, and suddenly I was hearing WLS 89, the Rock of Chicago, down in Middle Georgia. And the magic of an antenna at that moment caught me, and it is not left. So I really like antennas. We often talk about it's 90% of your station. The other 10% is the rest of it. And I don't always, my pocketbook doesn't say that I agree with that logic, but I think we all get the spirit that your antennas are very important. So this will be a little bit of a fast-paced cover of a half a dozen portable HF antennas. I sent earlier today email with a PDF of the slide deck you're going to see. I sent that to Nick. He's free to send that to anybody he wants. That way you're going to get the same slides that you see. If you're like me, you sort of watch something and you want to make notes, and then boom, the speaker moves on and you miss that one part. So you'll get all the slides here. So with no further ado, we'll talk about experiments with portable HF antennas. Now, as I mentioned, I love to design antennas. I'm a late in life ham, but went into commercial broadcasting. So at age 20, I led the development of a kilowatt AM commercial daytime station and learned an awful lot about putting all that copper mesh in the ground. And can't believe I had 3 professional people trust a 20-year-old with a considerable amount of money back in the day to get a station built. So what I want to talk about is these are some antennas I've come up with, begged, borrowed, and stolen ideas from various sources. They're all based upon 2 things. The ease of setup and takedown. We go outside. We're not putting a tower in the ground and going to live there permanently, although at what we call field day over here, which you have over on your side of the pond, some of our colleagues probably act like they're going to homestead and build a permanent location. Got to put it up easy, got to take it down easy, got to carry it with you, but you want optimal performance. Now, we sometimes use what we label as compromise antennas. And I don't believe every antenna is a compromise in the technical sense of the word. So those are the 2 elements, the 2 horns of the dilemma. Now, the 5 antennas that have all now been published in Practical Wireless, except one that I'm still tinkering with, and I will show that to you, are the Wavecaster Vertical, the Eiffeltenna Vertical, where you can enjoy fine dining there with your French cuisine, the Delta V Auto Loop, and while we're at it, let's just build a remote control battery powered antenna rotator since the loop is directional, an HF ground plane for 20 meters and above, and then a random copper stick for 80 through 10. And there'll be one more I've got on my workbench I'll tell you about at the end. So with not further ado, let's get started. In the April 2026 Practical Wireless, Don published the Wavecaster Vertical. And this one takes inspiration from someone I respect a lot, Colin, MM0OPX. He's pioneered the use of variable wired links and some brilliant vertical antennas. And he and I chat sometimes by email and things, and I have a great deal of respect for him. So you've probably seen his Varilink antennas. On this side of the pond in California, Chuck KK6USY published a YouTube video using a very small resin fishing reel with a vertical antenna. So kind of inspiration there. Now, the Wavecaster can be set up very easily using it just as a 40-meter vertical with a 1-to-1 unit, a 31-foot multiband vertical using a 4-to-1 unit, 29-foot random wire using a 9-to-1 unit. I'll be using some of the devices sold by LDG Electronics over here on this side of the pond. They tend to deal with the weather fairly well. Now, on the ground plane part, most of us have probably bought inexpensive ribbon wire, often used for computers back in the days that the parallel port was king on a PC. We had lots of ribbon wire cables. They radiated the heck out of RF when they were printing, but that's another story. So I bought cheap ribbon wire, pulled them apart. They make easy portable wires that we've traditionally used. However, I have in the last couple of years begun to use this Faraday cloth. It's much easier to roll up or unroll. And as far as I can tell, there's absolutely no degradation in performance. Now, there have been some hams that may use just the number of contacts they make to say it's better or worse. I don't know. It's a whole lot easier to put down, to carry, and to take back up. So I'll use some Faraday cloth with this. So on the left here, you can see this small resin reel, and it's not much bigger than what you see on your screen. It's so between $5 and $10 US, very inexpensive. So I've used also a carbon fiber fishing rod. I think squid pole is a term you're very, very familiar with. I've also used number 26 flexible stranded wire, and this is by the Chinese company BN TechGo. They say it's Teflon. Maybe it is, but it's flexible. You just about can't kink it up, and it takes to this reel very easily. Now, over here on the lower left is this odd-looking creature that photographers know well, sometimes called a super C-clamp. It's got crab claws on either end. They're what we sometimes call a funny fitting. That is, when you loosen it, it'll go in almost any direction. When you tighten it up, it's fairly firm, and it's fairly inexpensive. I know because I left my first one in a park, and it was not there when I went back to get it. I'll explain what that's used for. What I learned from Chuck was in this particular reel, drilling a hole on the inside of it on one end and putting the wire through it, then having a steel terminal ring. I don't advise inexpensive aluminum ones or aluminium ones. They don't hold up. This is a steel one, and I bend it at right angles after I solder the wire to it. And here's why. You see the other part of the reel where the shaft fits into this, it makes an electrical connection to this outer part of the shaft. Why is that important? Well, maybe better engineering minds than I can figure out a great way to use a reel without it breaking or binding or otherwise not working like we want. And you can see here a little close one for that particular one. Here's the finished product. And I'll show on the next slide how all this comes together. Okay, there we go. Now, you can see on the outside of that part with the shaft, there's a screw, and I use a ring terminal to connect that wire to the center of the coax, which I'll show you in a second. Here is the carbon fiber rod with it unfurled, and you can see here on my patio just outside of my garage here, you'll see how the wire, I used it to a banana plug and the ground plane to the braid side of the plug to take some measurements with. But you can use a more permanent fitting if you wish. And so you can see here it is outside of my garage. The C-clamp, as you'll notice in this one, it's not as much like I've got it in this picture. It's more of a brace. You don't want to clamp down too hard on carbon fiber. You'll crack it. I wish I could say, trust me, but I think I respected the carbon fiber at the very beginning. So I've yet to crack one, but you don't want to push it. And so it's really used best as a brace. Now, when I was at a park, there was a permanently mounted grill for barbecuing. And on the handle, this little thing would connect to the handle, and then the other end would connect to the pole, and it just kept it in place, and it sat on top of the Faraday cloth. And you'll see the little LDG clamp here. So that's how that goes. I've got a 4-to-1 on this one, this illustration. Notice I finally found a really good use for that doggone flexible tip that usually snaps off when you tend to use these things. Most of us will pull out that very top section and it'll be shorter, but here's a good use for it. Okay, now carbon fiber is potentially problematic. We've used fiberglass for a long time, and it's somewhat RF agnostic. You have other people that say, oh, don't use it. It will mess up your wire. Well, what does it do? So I wanted to get at least closer to the bottom of it, and I did an experiment. One was I did RF sweeps throughout the 20-meter band. And what I did was I took one piece of wire, and it's just loose, it's floating in the wind. I took another piece of wire and just taped it directly to the pole. And I took a third piece of wire that applied directly. One's directly to the pole, one's hanging loose, and another was copper tape directly applied to it. All these were 17 feet. And now it doesn't take a mathematical genius to recognize the virtues of 17 feet for 20 meters. That's a quarter wavelength. Well, look at these three sweeps. You'll see that it should be somewhere in this blue line. For those of you who have a rig expert meter, you'll see this is ant scope, and it lays out the bandwidths for the particular region you're in. So that should have the dip somewhere here, but it doesn't. What happens? I posted this graph in the RSGB technical group, of which I'm happy to be a member, and Dave G3PVH came back with this speculation. The pole has both conducting and dielectric properties. The jumpiness, where you see this real jumpiness, but when the wire is loose, you see the readings are very smooth. For those of you who don't yet know how this thing works, it takes sample points at every at every segment of frequency. I'll put it that way. It depends on how you set it up. The wider the sweep, the fewer the data points in a particular region. That's why when you do a really broad sweep, it may not be the most accurate. So when you have the wire hanging away from the carbon fiber, you see how smooth that is. You see the jumpiness when it makes contact. So Dave looks like he has a really good idea. The lowering of frequency is dielectric loading. Now, and so when the capacitive reactance on the meter readings, he articulated this. I greatly appreciate this because later we're going to take advantage of that. And we're going to make an antenna of which that's going to be put to good use, just not on this one, okay? So a little experiment here to figure out using that carbon fiber pole and how to avoid what it does to RF with having both conduction and dielectric properties. Okay, so it can be used at less than 31-foot lengths, but just don't let all the line out. You can use this as a 29-foot random wire. And at first I said, well, this will be easy peasy. I just crank it down to 17 feet. Bob may not be your uncle, but he's at least your cousin, and you're working. And the more that I would do that, the less I was getting a good sweep. And I thought, well, why is that? Well, dummy, you're making an inductor coil, which induces some inductance. So the shorter the wire and the more the coil, the longer you're making. So I was going at counter purposes. So I went, well, gosh, is that really going to be it? And I thought, no, that $5 resin reel is cheap enough. I just make a separate resin reel for 20 meters, and I just let the pole up 17 feet. I've hooked the wire onto it and run it out, and boom, you get a very, very nice dip. Now, this super clamp's only one option, but I encourage you, if you build it, to really use it as a brace rather than, clamping that pole. I added a rubber footing to the bottom of mine to reduce wear, as well as to keep it separate from the Faraday cloth. Now, on that business of getting it out into the field, easy carry, easy pack up. Now, I'm not an archer, but I hear there used to be a famous one over in your neck of the woods called Robin. And so this is an archer's case, and I bought one at a local store very cheaply. And since I've ordered some on Amazon very cheaply, and you'll see places with these fingers in this little rubber part for arrows. And I can put this in by clipping out some of these fingers, and you'll have a carrying case that would even probably go on an airplane if security x-rays it and they're okay with the contents. So it will pack up and carry fairly easily. And all this is fairly lightweight. So I used a Beach Boys motif in the Practical Wireless article. Take it easy, cast a few waves, catch a few waves, and hang 10 with this wave caster vertical. Okay, we'll move to the next one. Get out your tuxedo. We're going to France, and we're going to the Eiffel Tower, and we're going to make the Eiffel Tower vertical. Okay, here's a child's drawing of the Eiffel Tower. Never had the pleasure of going. I hope to make it one day. This one was in the October 2025 issue of Practical Wireless. Well, if you can't go to Paris in the spring, bring the Eiffel Tower with you. If any of you followed Jim Heath, W6LG, before he became a silent key, he always had a lot of interesting, curmudgeonly at times, videos on things. He particularly hated the gray-covered coax and tried to persecute that every chance he got. He thought you should spend money on coax and buy good. Obviously, he's right. He had one video that I saw that took an all-metal tripod that's usually sold for camera lighting. You're a photographer, you've got a dark spot here, you're taking a wedding picture, you're doing something else, and you need some light there. Well, there are these lightweight tripods that are made for photographers. Well, he took one and he used the center vertical strut to make an antenna. And I thought, well, what's really nice about that, sometimes if you go to a park or a public place, you'll have the people in charge not allowing you to dig in the ground. You can't put a spike in the ground, for example. But every park I've ever been to would allow someone to put up an umbrella that would just sit on the ground. So what if you just had this tripod and it just sits on the ground? And to boot, if you use Faraday cloth, you can protect the ground by putting out your fine dining tablecloth with Faraday cloth. I can't imagine anyone stopping you from using that. Now, you can combine that with a telescoping whip. Since Martin Jew made the first one some years ago, it's been copied and made, and it's been made better, and they're just ubiquitous. You can make a 40 and 20 meter vertical, and as a harmonic of 40, you can get 15. And I'll show you a little surprise that I ran into while testing. You can also get on 10 fairly easy. Now, I use counterpoint Faraday cloth for this. You can do it another way, but we'll see. All right. Here is a tripod. The trick is this. Many tripods have a metal bracket here. That's not a good idea because it doesn't isolate these legs. With a plastic one, this is a vertical piece of metal that telescopes up, and it's just like any other vertical. It's a piece of metal. I'll show you what I did. Now, different ones, and I bought one from the brand, it's from China, really, NEEWER, newer. It's an 8 foot, and it's air cushioned. If you don't know this and you are looking at it and undo the knob, it can knock your eye out. So you have to be careful. So it raises itself. So what I did, I took my little Dremel tool cutter and I just cut this top off, and I took a standard 3/4 inch coupling nut and I just cut that off. I ground down one end of the coupling nut so it would fit into the top section. I took out any paint on the inside, drilled a hole, had a nut and bolt, and there you've got a pretty good connection. So if you think about this tripod, if you were to use it at its full length, about 7.5 feet plus 17 feet, that's about 24 feet. Well, that's probably not resonant on any of the bands we want to use. And so what you need to do is measure out what you want to use. So I dropped the whip to 9 feet to get around 17 feet there. And it works marvelously. Before we get there, these sections need to be taken apart. They manufacture things very differently, as you know. Let me mention, I have several of these. I've built several of these, both for myself and for fellow hams here in the area. Some come in black, some come in aluminum colored, and so I've got pictures from each one. Take them apart, grind the paint off. This is a little rubber insert that protects the air that'll make it go up and down. Whether you use it at this point or not, it would be really up to you. But I'm a stickler for lowering the resistance in connection. Sometimes we make an antenna or something and it works great, and 6 months later it works not very well. Well, why is that? Because very often you've had corrosion, rust, or something else that increases the resistance. So what I did is took some inexpensive copper tape. I wound it around this part, and I got just so brilliant. I said, I've got to flow solder on this, right? And one of my mistakes I make sometimes is I put too much solder on. And the first one I built, I flowed solder around this and was so proud of myself, but I put so much on it wouldn't go back into the bottom section. So you learn from your mistakes. So learn from mine. And that makes a good solid electrical connection. You can see the copper showing through here as you put this back together. And if you take one thing from this, check continuity. You'll see I'm making sure I've got enough of this exterior coating off to make sure that there's electrical continuity. Manufacturers use a lot of sophisticated electroplating methods today, and you just sort of have to be sure you've got continuity. All right, how do we connect the antenna? Here at the bottom of this, and you can see very clearly, these are plastic braces here. I drilled a hole. This is a round hole, and I've got a hexagonal coupler nut. So I ground it with my grinding tool so it would fit. Made a fitting, because what you want to do is the opposite of what your intuition wants to tell you to do. You want the center braid to connect this vertical, right? And you want the exterior to go to the Faraday cloth. So that's the one thing you want to make sure. This is a typical mobile mount with a 3/4 inch nut. And you can tell I just love grinding, can't you? So sort of put this together, and this will go in as your feed point. And it works much better than I thought it would to begin with. Here in my garage, you can see a piece of Faraday cloth. I have it just standing here. I've got the Rig Expert stick connected to it. I got real fancy and put a grommet in and a bolt. I'm going to do it right, you know. I had two ground wires because, you know, that spreads the resistance, and I connected it, and later figured out you didn't need but one. I mean, two doesn't really help it much, so save a little bit of effort. And on the other hand, making this bolt connection, it's all well and good, but just putting a ground connector with an alligator clamp seems to work just as well, and it's far easier. So you can see that there is, in this middle slide, this little white resin insulator. And that's the key thing, because it keeps the outside bracket from connecting to the vertical radiator here, okay? And again, double check continuity on this. Okay, this is at my friend Mike in 5 Delta uniform. He and I are partners in crime on many things, and it's really good because he's a lawyer. So if you've got a partner in crime, I advise having a barrister or an attorney or something. So you can see this is on a patio. I've got little leg weights that you might buy at an athletic store to put on your legs if you're running to strengthen that, but they Velcro onto the legs if you've got any wind. And you can see this is tilted just a little bit. 20 meters, you see our sweep here. Our feed point impedance is about 47 ohms. It's got a little inductive reactance, but just a little over an ohm. We sat there and worked with his Xiegu G90 at this patio table all up and down the East Coast from Delaware to Georgia using 20 watt sideband. Now, the conditions of the band that day, I don't remember, but the SFI and the sunspots were not terribly good, but we had no problem. The guy in Georgia was on the coast, and he had one of those antennas in the salt marsh, so he had a very, very good signal. But he said we were 20 over 9, and I must say, I thought he was pulling our leg to begin with, because in poor conditions, that's unusually high meter reading, even with the 5.9 next tendency. So it worked very well on 20 meters. Well, we all can't be on 20 meters, and often we want to use 40. So we can do one thing with this. If you take a note here, you can see there's a little coil here in the picture. You can barely make it out. But a center-loaded vertical is said to be more efficient than a base-loaded vertical. So we could use some standard website formulas or dig out your calculator and look up in the book and calculate it yourself to see what kind of inductance do you need at a certain coil height for a certain antenna length for a certain resonant frequency. Well, if you look around, if you don't build your own, most of the commercial inductor coils, they will sell them and say, use this with your 17-foot whip and you'll work the world on 40 meters, but they don't tell you what the inductance value is. So I had a number of coils in my antenna parts box and things. And I said, I don't really know what they are, so I'm just going to measure them. Let me point out one thing on this. Just ask me how I know, because I made a lot of these mistakes. You're tempted, instead of reducing the whip, to just reduce the tripod. Well, what's the problem there? You will break that connection. Remember the copper, and it's pull full length, makes a good connection. But if you pull it down, then you're breaking that connection. So you'll have a much shorter antenna than you think. So now, I took several coils, and here is the MFJ air wound coil that they sold, particularly with their big stick, which I pushed Martin to build, and it outsold the big ear, which is the dipole, 10-1 over its life. Here's the one from Australia, from Mad Dog. Now, these are adjustable, right? Here's the one from China with Chelegant, the JPC7. Here's one from a U.S. company, Wolf River Coils. I have that. They make a coil just for their antennas called the Sporty 40. And then here's one from China that's clearly a clone of this. And I have a decent workbench. I have an HP 4275A LCR, lab quality LCR meter. And then one that I picked up by Matrix MCR 52. It's a Chinese built. And it gives me a good balance. So in measuring the settings on each one, from the lowest setting, the least inductance, to the highest, this might be a decent reference chart along with the Q coefficient. How good is that? What's the quality of that particular inductor? And when the manufacturer doesn't tell you, then it's kind of good to know that, because it will help you figure out that chart. I talked to the people at Wolf River Coils, and they said, we could always call us and ask us. And I went, at 2 a.m? So it's always good to have some measurements. So I put that out there on my website. Okay. Here out in front of my my garage, you can see I've got it set up here. I used the JPC7 coil. And here's a trick that Michael KB9VBR, very popular POTA YouTuber, he sells some J-pole antennas. I borrowed this trick from him. Have a jumper cable. You can use power poles. You can use anything really, as long as it's a good connection. And you can bypass this coil. If you think about, you don't want to take the whole thing down. If you can reach up and put this together, it bypasses for 20 meters. Pull it apart and you put the coil in, and there you're on 40. If you'll pre-measure that and mark your coil when you're out into the field, then you've got a good match on 40 and 20. And while you're on 40, you should get a fairly decent harmonic on 15 that a tuner would certainly make your rig happy. So the whip's out at 9 feet. So plan accordingly, but this is a fairly easy one. Now, I was in my garage. Now, notice, I just wanted to make sure the electrical connections were okay. I didn't put anything on the top of this thing. It's sitting there by my Toyota RAV4 on a Faraday cage. My garage door's down. Here is a wall of a lot of my portable equipment. These are wire shells. You got wire here, metal here, and you got an electric car that's always running, whether you've got it cranked up or not. So that's not going to do anything, right? Well, I hooked it to a Xiegu 6100, and I was just testing things. And I thought, okay, I'll just put it on transmit, send CQ. What the heck? And lo and behold, some 900 miles away, Paul, AA0DY, worked me from Colorado Springs at the foot of the Rocky Mountains here in my garage on 10 meters. So I found by surprise that this is not a bad 10-meter vertical, easy to set up, and it will work. So that gives you 40, 20, 15, and 10 for an easy up, easy down vertical antenna. This is for me, $16 Amazon zippered tripod bag. You got all the parts in it. I use some RG316 coax at times for portable use. The tripod is in here. The little coil is in here. A counterpoise cable that then connects to the Faraday cloth, and then these blue weights that will help deal with any wind. So it packs down to an easy to carry, easy to pack. It's ready to go, and it's something I can just pick off of that wall of my portable operating gear. Okay, well, that's 2 down. Let me get a little sip of water. Now, like you, I've tinkered with loop antennas, and I had published a paper earlier about horizontal loop antennas, and I made the argument that so much of what's in the ARL handbook, a little bit of what's in the RSGB antenna handbook, not so much the Rothamel's book. I greatly admired that book. I got the English version, and it's, as you know, if you've seen it, it's thick. It'll stop most doors, but it's a great reference, and they actually give you the source of what they're saying, which I wish ARL did a better job than that. So I made the argument that for a horizontal loop, don't just feed it with 450 ohm ladder line. What does that assume? That assumes 50 into 450 is what, about 9? That assumes it would be a 9-to-1 relationship. Measure the inductance at the bare wires. Okay. So here's another antenna. It appeared in the January 2026 Practical Wireless. And I call it the Delta V loop, but I'm calling this one the auto loop. And there's a good reason for that. There is one on the market uh, by Chameleon. They're very proud of it. It's between $400 and $500. It's a Delta loop with a fixed 5-to-1 balun, and it's a nice looking antenna. And those that they give it to that do YouTube reviews of it shows it's wonderful. My friend Steve McGrain, temporary offline, he published one. It was sitting on the ground, and he had a flat SWR swoop, and I asked him about it, and I haven't yet gotten an answer back because that's a bit odd for a Delta loop, for any HF loop. Larry Seebeck, if you're familiar with his term, he's been Silent Key for a number of years now. Lawrence Seebeck published quite a bit. And I often hear friends say, well, that Larry Seebeck, he was a heck of an engineering professor at the University of Tennessee in Knoxville. I said, why do you think he was an engineering professor? He must have been. Look at all the antenna stuff that he published. And to understand that, he must have been an engineer. I said, Larry was a professor of philosophy, and he was a darn good philosopher. And he published papers in the field of philosophy. So I guess it just goes to show that not every astute, educated, and knowledgeable amateur has to be an engineer. It might help. But Seebeck's models tell us a lot. And he tells us that there are some things that really make a difference for HF loops. And that is the design frequency tells us what the harmonics are going to look like. And the height above ground makes a significant difference. And it can change that impedance. So let's go into it with that mindset. Height above ground and the band or the frequency will change a loop's impedance. It will change its takeoff angle. And on the harmonics, while it's not on the slide, it will increase your gain. Okay. We can build a better one, in my opinion, than the Chameleon loop with an enhanced design, and it will match 80 through 10 meters with the glaring exception of 60 meters, much better. Okay, here's the design. Just imagine a mount point of some fabrication, which I'll illustrate in a moment, and imagine two telescoping whips. If you're old enough to go back in the early days of television and the nefarious rabbit ears, and you would wiggle those things around. Some people, if they got ghosting, would put tinfoil on them, and suddenly it would be clear. So imagine a set of rabbit ears, and like Chameleon does, with simply a wire with alligator clips on it that will make the V of the V loop. Now, what's different is instead of making it a fixed balun, why not put an automatic tuning unit directly at the feed point? One that's battery powered, RF sensing, so when you transmit a nominal tuning cycle with RIDI or CW or something that's got a carrier, then it will fire off and try to get a great match. You can mount it however you want to. I'll show you something that two things that I've done, and you'll see how that works. Well, the 17 foot by 17 foot by 25 feet 4 inches by itself is resonant at the bare wires at just over 16 megahertz. Now, at the time, MFJ, before they decided to stop manufacturing, I had a deal with Martin for first dibs on it if he wanted to make it. And I began looking at the different matches, 2-to-1, 4-to-1, 6-to-1. Each one would be a caveat emptor, buyer beware. You buy one, you're going to get one band, but not the others, and so on and so on. And so I came up with this idea, why not do this directly? There is another ham who used to be the editor at ARRL, Kurt Kleinschmidt, that lives in Minnesota. He lives where it gets very cold, and he has a loop, and he has a tuner right at the feed point. His problem is he has to have a heater in a box where the tuner is, because the tuner won't work when it gets below freezing. So I didn't come up with this idea totally on my own. Now, no radios are needed, and it's generally quieter on receive. Okay, I go down to an inexpensive store like Walmart over here in the States and buy a $5 resin cutting board, and I draw out what I want. You see, I made some holes on here that I had to go back and drill again. So I've got a couple of things here. These are coupling nuts, standard 3/4 by 20 coupler nuts. These are little U-bolts. Now, they're not the standard U-bolts. These are the smaller ones that you might see on a tugboat or a fishing vessel that clamps steel cables together. You might have 4 or 5 of these along an overlap, the pieces of cable. And they have lock washers, and you can clamp them down. So these clamp these coupler nuts down very firmly on here. I used Velcro, and I used the AT100M, the ant tuner, and I've found it to be, for my experience, the most reliable build of the open source N7DCC automatic tuning unit. Now on the back, you'll see I've got a cable that has the center cable going to one leg and the braid going to the other, as you see here. Now, this is simply a rolling painter's handle where you're going to paint a wall and you've got a roller. It was about $5 at a big box store, and I cut it off here. I just needed the female painter's pole here so I can attach it to a painter's pole, which is a 3/4 by 5 ACME standard. So that'll be clear here in a moment, but that's kind of the prototype for that mounting unit. Now, you can see here, it's here in front of my garage, and you'll see it sitting on the ground. I haven't pulled out the whips yet, but here is the wire, and I'm using this BN TechGo flexible wire. It's 25 feet 6 inches. That puts just a little bit of bend of the ends of the whips, and I've got a loop with a ferrule over it, and one side of the ferrule is crimped so that it won't, it'll go out and it will find its own tension, if you will. But this will be, the alligator clip will be there to make the electrical connection. This is the lasso. It's harnessed by the ball on the end of the tip, and you do that on either one. Then you pull one out, pull the other out, pull the other out until you get it all up in the air. And it's almost mounted on the ground here. Now, lo and behold, every time you fabricate something yourself, you get some email from AliExpress, right? Or Banggood. And I found for about $25, this manufacturer, NV Archer, had built something for just a dipole. They weren't building it for a loop. And they fabricated this thing. This is a resin stock. It's very sturdy. And they've already got, now these are M10 connectors, not 3/4 by 20. And they actually have what they call in their translated Chinese to English, a fixing rod. Now, what's really neat about this fixing rod is it has 2 threads. One for what I'll use the technical language of bigger opening versus smaller opening, and they are the metric standards that you would see largely in photography. So what I did was I took these 2 holes, I made a mounting bolt, and I put a piece of steel across it, just bar stock steel, cut it with a Dremel tool, and I mounted a magnet and drill holes through it and smoothed this off. And I mounted steel on the back of the tuner. So this tuner, I can just click it to this mount point and it's not going to fall off. You yank the coax, you'll pull the antenna over before you'll pull this off. This is a neodymium earth magnet, very strong pull. you don't pull it away, you twist it at an angle, and that's the trick to neodymium. It'll lose its pull if you twist it at an angle. So here is a mount of a different mount point for this particular antenna on a tripod. And you can see, and I bought a Bogen Manfrotto from Italy. When Bogen and Manfrotto merged, they had a lot of the traditional surveyor's tripods. You can find the tripod without the surveyor's head for about $40 US on eBay every day, because to a surveyor, the head is the most important thing. We don't need it. It's a very lightweight but very sturdy tripod. Okay, and there's a picture of it. You've got a mounting point on the top. Here in my garage, you'll see it, and this part will go up and down. And so here we are with my friend Mike in 5 Delta uniform. We're at a POTA site here in almost downtown Jackson, and it's mounted on tripod. And he is there with an ICOM 705 without a tuner. Remember, the tuner is at the antenna. And so I don't remember how many contacts we made that day. We did draw the park directors out just to see what we were up to. We told them what we were up to. Instead of being negative, they were thrilled, and they offered us the promise of using the facility for field day, and we could stay all night if they could come. So we sort of got a bonus there in winning over friends that sometimes can be enemies if they don't know much about amateur radio. Okay, so how does it work? Well, I did a sweep, and here was what I did. For each band, I would do a sweep, and then figure out the range of impedance for this. And when you get the range of impedance, we want obviously a match to 50 ohms. And so what would be the equivalent balun if we were using a balun to transform our feed point impedance to something that would come close to matching? Well, on 80 meters, we'd have a 3 point, almost 4 up to a little over 7. 60 meters, I've yet to get a loop that I built to really do well on 60 unless I designed it explicitly for this frequency. So there's something about the math there. 40 meters, here's ratio. Here's my point that I made this chart for. If you pick one of these baluns, look at what you're doing. You're optimizing it for one band, and it may not be that great on another band. And Larry Seebeck, the philosophy professor, told us this in his models of HF loops a number of years ago. Okay. In that park that you saw in the picture, this is, I think it was about 2 hours. And so these are combined spots for 40, 20, 15, and 10. This whisper beacon is a Zactec beacon at 0.2 of a watt. When I have non-hams ask me, I go, you remember that 60-watt bulb that we're gotten away from? Oh, yeah. Well, this is 0.2 of 1 watt. And I've never had anybody not just be totally amazed that limited power can go where we go. Okay, so it does transmit a signal that we can hear under whisper there. All right, how does it, and I've made a number of contacts with it since. This is a larger bag than you saw for the Eiffel antenna, and it was probably $25 on eBay, but it has a nice set of pockets here for the tripod, for the other parts to this particular build of the antenna. And you got room for, maybe over here, a can of Guinness or whatever, and a sandwich or two if you want to pack some things into it. So fairly easy to pack up, fairly easy to take down, pretty easy to tune because it's going to tune itself, hence the auto loop. Now, one of the things that Seebeck told us, now on some bands that Bogen Manfrotto was nowhere near a quarter wavelength. if I'm a little more serious about operating, if it's a day-long portable operation with my team, this is a standard patio garden mount for an umbrella. In the fall, at least over here, the big box stores like Walmart, Lowe's, Home Depot, they want to get them off the floor. I think I paid $25 for this one, brand new. Take the box, check out, and goodbye. We don't want to see it anymore. We'll see it when we get stock for next year. This is called an extender reach pole. They sell it for indoor dusting, up with high ceilings, cleaning ceiling fans, and they have this little neat little top that goes on, and this is a standard painter's pole. Well, I mounted that loop on the top of this. If you get it up to 30 feet, which begins to be the sweet spot for most of the HF bands for this thing, you might want to think about guying it if you've got any wind. I've done it without that, but you want to be careful. I've got a piece of PVC pipe that fits in here, and I've got a soft material on the inside that doesn't scratch up the pole. And although it's more work, soda aficionados would not take this with them. This is about 45 or 50 pounds. But if you're going to a park or you're going to set up portably and you want to be a little more serious about it, I've occasionally used this particular configuration. Now, that thing's directional, right? Well, most of our rotators are for light to heavy duty. You may have seen the news that Martin Jew sold two of the brands, High Gain, which makes rotators, as well as Cushcraft. They're typically light to heavy duty. There's almost no battery powered lightweight rotators on the market, except for a couple that might be hard to get, and they're for satellite or ASL. Now, RF Finder in the U.S. took over a product from Portable Rotation, which had a battery powered rotator, and they want $1,600 US for it. Well, why not just build a lightweight portable directional antenna? Now, this one is my first design. It's simple, but it's fully portable, and it meets the following design specifications. Battery powered, not AC. Out in the field, we want battery power. Wireless remote control. I want as few cables as I can. I'd love to have just the coax cable to the antenna. Now, I built one that meets this. I built a smaller one with a handheld control and a small 50-foot control cable and put the circuit board in a plastic box. I'll show you, I've since made this wireless. I want it direction seeking. That is, I want it to keep up with the bearing of the side bearing of the antenna, right? At right angles to that loop is typically the peak of the signal reception. And I don't want to have to get up and do a protractor or with a loop. I want to know, right? Now, I want it to attach to a painter's pole fitting because I've standardized on that. And by the way, remember that $1,600? I want it to be not very expensive. All right, here's what I came up with. I studied motors a good bit. I want a low speed. You might think, why low speed? Because you'll overrun your optimum point if it's too fast. You want it a little bit slow speed, but you want high torque. You want the torque to move as much of a payload as you're willing to put on it. And I found this motor here on Amazon. I don't remember the exact price, but it wasn't very much. Now, over on the right, you'll see this motor is built into this PVC contraption. And this is called a compression tube. If you're a plumber, you'd know a lot more about it than I do. This is a compression tube. It fits in. I took my Dremel tube. This is a square top. I cut the ears off of it so it would fit very tightly, and I made sure that it was mounted so it wouldn't turn inside the tube. There's an old saying that one of the cardinal rules of homebrewing and amateur radio is the finished product must be ugly. And I was proud to see I was successful on this one. It's nothing much to look at. Here are a couple of, I call them hose pipe rings that you tighten with a screw. And here's a contraption I'll explain in just a moment. And this is a 12-volt Talent cell by the company Talent. They're used if you want 12 volts and that sort of thing, and it Velcros onto it. Well, what is this? This is a remote wireless control device that will alter both directions and speed. At the time, it was the only one that I could find on the U.S. market that would do both speed and direction. You turn in your rotator, up, you went too far, then you come back, up, went too far, then you come back. And so you want, I believe, both of those characteristics in a rotator. Well, how am I going to know which direction it's going to go in? Well, here's where some of the folks in China come in. A company called Wit Motion. This is one of a half dozen devices they make. I paid $5 US for a box of 6 of these. It has a USB-C charging port, a soft button, and it has Bluetooth in it. And here's the app. It's free that you get. Lots of data. It will do Azelle, but I'm not doing that now. All I want is the bearing. And so I can see on the app what the bearing of that is. I used an L clamp, a little Velcro, and a C clamp. So it will pop on, it's not shown here, but it'll pop on the top of that rotator. So you pop that on. You turn it so that it's broadside to the loop, if it's a loop in this case. If it's a Yagi, you want it toward your direction part. And as long as you do that, then this app will tell you where that's pointing. Here is the fob from Gamma Electronics. I bought this. And because of a slide I'll show you in the next slide or the next one, I think I paid $125 for this US. Pretty expensive, probably the most expensive part in it. We can do much cheaper thanks to China. All right, how does this work? This is just in my garage, and I'm just demonstrating it backwards, forwards, and that's just a little PVC pipe. That little fitting is actually for another antenna I'm working on that I'll tell you in the show you in the last couple of slides. You can see it's just mounted. Again, it passes the ugly test. Yes, it's ugly. That battery will run all day unless you're simply running that rotator constantly. That Talent cell will last pretty much all day. Okay, now, as I said, build something, and China has built something cheaper and probably about the same. I found this device. It will fit in this case. It does direction and speed for $21 US. So I took my cable-based smaller version of that, and I made it wireless as well. So if you build this, I wouldn't spend $125. It's the industrial version, but this will certainly suffice to use out in the field. So now, why not add a rotator? And we can certainly do that with off-the-shelf parts. Now let's make one more shift, and let me talk a bit about what is sort of all the rage right now in POTA operation. It's the POTA Performer. And the guy who did it, I think KG something, GER, I forget his name, brilliant guy, won a QST award for that design. He basically said, let's take a vertical antenna. Let's recognize clearly and very soberly that with the ground counterpoise or radials, take your pick, that we're losing a lot of power into the coupling of the ground. It's endemic to a ground-mounted vertical. I do it. You've probably done it. We'll do it tomorrow. That makes it convenient being on the ground. So he said, let's raise it up off the ground and put one raised vertical. And as we know, Rudy Severns and QEX and many others have shown that the length of radials coupling to the ground may not be as critical because you can't model that stuff anyway. It gets complicated, depends on the ground. That's why Walt K4OGO, I think is Walt Hudson's call sign, Salty Walt. That's why when he's at the beach, he gets that saltwater effect. You get great ground like that versus out in Utah where you've got dusty rock bearing very different counterpoint. So it's hard to do that. But when you raise that radial and you tune it, there is a claimed directional effect. I don't think we've had actual good data that demonstrates clearly that happens. Guess what? If you're out west and you have that pointed east, you're going to think it's directional. Why? All the hams are east of you. So I'm yet to see a really good experiment demonstrating a demonstrable direct effect, but I'll give that for what it is. Now, I believe that antenna, raised radials, can be easily put into the traditional ground plane literature. And in that literature, just to kind of review something real quick, on your side of the pond, Tim G5TIM has a great channel. He's dealt with a lot of this. Salty Walt, KJ6ER's QRZ page is another, and we use that a great deal. Now, I wanted to build one that used a ground plane that had these characteristics. I wanted a single band for 20 meters. I want to optimize it. 20 meters, we can adjust the elements to higher frequency bands. Okay. I want to reduce ground losses, to have tuned radials on the ground plane versus a ground mounted vertical for reasons I just talked about. I wanted what I'd call deployment efficiency, so I can take it, set it up, count on it being somewhat tuned out there, take it down, put it up, take it back. And I wanted the height above ground to be sufficient enough so it would be the most efficient vertical that I use. Okay, now that's kind of high goals, I'll admit, but we'll start there. So the theory behind this with a quarter wave radiating element assumes in the literature that this is a solid surface and a quarter wave diameter. And we don't actually get that usually. We simulate it with up to 4 quarter wave radials, usually, sometimes less. Sometimes that distinction doesn't make a difference. But what you'll find is the literature being far from one voice. And I have a lot of respect for Ian Poole and his website. And he and I are friends on Twitter and share things a good bit. Quoting his website, the radiating element is a quarter wave and the radials are 12% longer. Why is that? Usually there are 4 of them, 3 at a minimum, but you can use up to 6. This is a true unbalanced antenna with a feed impedance of around 50 ohms and therefore a good match. Okay, 12% longer on the radials and it'll be 50 ohms. Okay, let's continue. Let's look at another one. Let's look at another website here. I believe this is on your side of the pond at M0UKD. Fantastic website. And he'll give you some estimates there for a 20-meter ground plane, quarter wave ground plane, this one at 14.1 megahertz. And he makes the argument, as many others do, that what happens is if these are at 90 degrees, then it's less than 50 ohms. So to get to 50 ohms, we'll make these at 45 degrees. And otherwise, they're at about 25 ohms. Okay, so there's a different approach. The first one, you make them longer. It adds to the feed point impedance. You tilt them. Okay, it raises that feed point impedance. Okay, getting different suggestions. They may both be very good. So models of this will say that the feed point impedance for a ground plane will be far less than 50 ohms. Well, I went back into the literature, and IEEE wasn't called that then. It went by various names. Stuart Ballantyne in 1924 published the first paper I could find on the expected impedance of the vertical monopole at a quarter wavelength. He said it should be a little over 36 ohms. So then we can say angling those radios to 45 degrees may reduce it about 13 and a half ohms and get to 50. There are other methods. We can put an antenna tuner at the feed point. Okay. You can use an L network, a matching network. You can use a coax stub. At 20 meters, how long would that coax stub be? Maybe longer than you want hanging out there. You can use sloping radios. And the last one is an off-center fed adjustment. And I ran across a website by Dick Reed, KB4 OBI, and it's fascinating. I learned a good bit. I thought I understood the OCF antenna, but I realized what I didn't understand about the OCF principle. So the key mechanical point for this as we go into building one is the mount point for the radiator and the radios. Now, I first built one of aluminum and steel hardware. It's very sturdy. It would endure permanent outdoor mounting if I wanted to do that. Now, Chelegance makes a little kit of parts for a 2 radio mount point. The one I built is 4. And you can adjust it for either 90 degrees or 45 degrees. I did that. I'll show you some results. Later, as you've seen, this is a theme here in this presentation. As soon as you build something, you'll find something from China. There's an aluminum machine mount from China on AliExpress. It's much lighter. It works very well. It has an opportunity to put guy rings in it, and it will handle 4 90-degree radios. I recommend that for the work versus the cost. And height above ground is key on this because you want to reduce, you're going to have an independent ground plane. You got to reduce the coupling to the ground, right? Okay. So when I began, here's just some, an L bracket bar stock off of eBay. There's a company I buy some of these things for. They go by the truckload, the scrap from manufacturing sites, and they have all this, they sort it and they sell it. Using our friend, these wire clamps, couplers, a mobile antenna mount, and U-bolts. And you can see I fabricated this up, drew cross things to measure, and here are 4 radios, and here's the vertical one. It's insulated from this point because this is all the ground plane part here. All right, pretty rigorous, pretty robust. Got some oohs and ahs on Twitter when I published these pictures. That's proper hamming. Well, I don't know if it was or not, but it's heavy. It's heavy. It might take a lightning bolt. I'm not sure. Now, in the back, I've got a PVC pipe, and again, a female painter's pole, because that's what I want to connect to. So you can see the fabrication bit here. And here on my workbench, you can see what that resulting would be, 4 17-foot whips, 17 being the quarter wave for 20 meters. And I put a little choke together here on the bottom of it, and there you go, 20-meter ground plane. Well, we'll continue the story. Here's the Chelegance antenna kit. Now, I bought this never intending to build the antenna they were selling me. I wanted the parts. This part right here was the key. Here's the little 1-to-1. I just have that in my junk box. I didn't want to cut these up. And this is the key thing because it allows you to change the angle of the radios, which these things bolt to this and allow you to do it. The JPC7 shortwave antenna kit, one of our Eiffel antenna tripods, a couple of more whips, and then Chelegance sells these 1-foot extensions. Remember that advice to make them 12% longer to raise your feed point impedance? Okay, I'll give that a go. Okay, so you can see here, you can angle these at 45 degrees. Now, I'll tell you, shop around. I found 3 2.5-meter whips for $25 shipped on eBay. This was a junk shop. They got these things in, didn't know what they were. Take them, $25. I'll mail them to you. So that was a bargain. I built a cable for the center part of that connector here with a ring, and then a jumper that would connect both of the radials here. And you see it mounted in my garage here. All right. Outside of my garage, I put this up for 10 meters, and you can see it's almost on the ground. And it's up. I wouldn't leave it out in the wind. I was just testing. Well, here's the sweep on 10 meters. Not bad. And what was odd was the impedance was right at about 47 ohms, very close to what would be pretty good. Now, this is higher than Ballantyne's figure. I'm guessing that closeness to the ground added to that. We don't know. Now, I test the difference between 90 degrees, 45 degrees, and 12% extensions on the next slide. And I just mentioned this just to show you the literature, excuse me, it doesn't speak with one voice. And here's where experimentation can come into play. Now, I have a park nearby that I go where I don't have a lot of gawkers wondering if I'm searching for Martians or something like that, and they don't look at me very oddly. And I did with 90-degree angle and going from 90 to 45, what happens? Well, it does increase the feed point impedance. It just doesn't increase it quite enough. Now, notice this bottom one is only 5 feet off the ground. And these are 15, the top two are 15 feet off the ground, which begins to make a difference. So the jury is still out. The extensions kind of don't do much there. That 12% suggestion, at least for me, didn't seem to do much on 10 meters. So what do we do here? Okay. Here's the alternative mount. You saw that big boy that I built versus this one for $20 or $25. I'll buy this one. These small screw eyes can go in here for guying. You'll see this. These are M10s. These can fit easily on a mount point and a painter's pole adapter. And suddenly you've got a ground plane that you can accommodate a painter's pole. It's what I recommend for kind of little money, really. So if I take a 20-meter version of this, and I go out to my park, and I believe this is 20 feet above ground, you'll see the sweep. It's a little short at the complete dip. It's in the band. It's about what Stewart and Ballantyne said you would get, 35.7.8 ohms. So almost exactly what Ballantyne's original paper said. Yes, you can tweak it a little bit. Here on Whisper, you can see it was omnidirectional, and I did work a few people who were was giving me very strong signal reports. So even with 2 radials, it's not bad. It's really not bad in terms of being efficient. Now I then went, okay, let's take this mount, let's take the radials 17 feet long. And you'll see you're beginning to draw a crowd with this thing you have built out in the park. That's a fair amount of metal. And I wanted to take a look, and you'll see my Rig Expert stick is connected directly at the feed point. I use my phone and connect to this by Bluetooth, do my sweep, email that to myself, the touchstone file, so I can analyze it in more in depth. I highly recommend that. It's been a godsend to me for building and testing antennas. Now, with this gargantuan beast, I worked every station I called using an FX4CR 20-meter rig on sideband on 20 meters. And most of them said I was 5'9". So my impression is that as far as it being efficient and how well did it work, it seemed to work very well. Now the problem, Okay, and I'll show you here. It matched pretty well, 1.8. Within 15 minutes, Whisper was hitting Australia and Africa. So, I mean, if you take a look at this over 30 minutes, okay, 490 degrees and all that. So, but it's big. It loses out on my criterion of being easy to assemble, disassemble. Now, so let's take the off center fed approach. And if you go to Dick Reed's website, and I've corresponded with him, and he said I was the exact ham that he did this for. What if we want to do 4 radials and use the off center fed approach? Well, what that does, it basically says, what do Cushcraft, Diamond, and Comet know that we don't? You look at their ground planes, you'll see that they'll have a vertical radiator that may be longer than what you'd expect for 2 meters, but they've got a couple or 3 shorter radials. And they're at angles. What do they know? Well, he argues they're using the off-center fed approach. And so the approach here is to have a longer vertical. So I immediately ordered the 25-foot chameleon whip that they've come out with, and then using the 17-foot radials reduced down. And I've gotten very close. This one isn't complete. When I do get it complete, I'll send it off to Don and see if he's interested in publishing it. But I do believe that you do this, you get it optimized, then you get the measurements for 15 and 10, and suddenly you've gotten an HF monoband, very efficient HF antenna. And so I'm not done with this one, but it's been really, really interesting, and I'm looking forward to doing the final tweaks on it to get the measurements done. So there's the ground plane, and you can see what this would look like. The formula based would give you these thus and so measurements at creating this particular radiator. We'll see how it works out. Again, apologies for it not being completed, but it's certainly well underway. And I think it takes the things like Proto Performer, which might be easy enough to set up, but I think it might certainly pass the test of greater efficiency, which we all want. All those 5 watts, right, for operating QRP. We want them all in the air and not as much on the ground. Okay, remember we said this is supposed to be solid in theory? What if we take something like this and we take the Faraday cloth, and if I'm really nice to my wife who has a sewing machine and does great work, I built a skirt for this and I clip it to these 4 radials and I go back and do the measurements. Would that make a difference? I don't know, but I'm going to find out. So it's funny what you think of in a hospital bed. All right. Now, the literature doesn't speak with one voice on the mechanical configurations, and I'm not saying anybody is wrong. I'm just saying they don't say the same thing. I think the OCF adjustment offered by Dick Reed's website is a good approach. It's based on principles both verified by models as well as in manufacturing realm. But at the bottom line, having improved efficiency for HF verticals should push us to experiment for antennas that are easy to set up and take down, and with portable operations simply being more efficient, we're going to get more signal into the air instead of on the ground. Okay. Well, now let's go to another one. This was published in the February 2026 issue of Practical Wireless. And I believe there's an old saying, I think I heard it from a rock and roll band, about taking a walking stick and going for a walk. Well, what if your walking stick could work as an antenna? And you remember the problem I had with the carbon fiber pole and what was the dielectric coupling that I was advised. I saw the relatively new YouTuber, Ben Eady, VE6 SFX, ham radio rookie YouTube channel. And he was going to use Faraday tape. And he's not done that. He's been busy building other things. He built some radials from Faraday cloth and stuff. And has a company and selling stuff. And he pretty much said the Faraday antenna, he it's on the back burner. Well, I said, I'm going to prove this won't work. I had to be negative. I'm just going to, this can't work, that carbon fiber pole. I was wrong. And it's the best way to be wrong. You think something's not going to work and you find out that it works, and surprisingly well. So I use copper tape. If you look at a table of conductivity, you'll see that copper has better conductivity than does nickel, which is the main ingredient of Faraday cloth. It's a fabric of nickel with some copper. So theoretically, this might be easier to use. And copper tape at hobby shops is very inexpensive, even though copper itself is pretty expensive. I will say that Faraday tape might be less fragile. So I don't know what the velocity factor is for metal tape. Now I could calculate it and do a little work. And so modeling this antenna is very challenging. But what I did was I said, if what I'm hearing from the RSGB technical group is valid, and it sounds like intriguing interpretation, it changes the relationship of the expected RF length. Remember the diagram? 14 megahertz. It was down almost at 12. So our typical formula, it gets altered with what we would expect. Can we make that an asset? Well, here may be how we can. So here's that graph again. What if we take this and see if we get a resonance point that is not on any of our bands? That's one of the criteria for a random wire antenna, right? Well, that's what I did. I took the copper stick and did this at the bare wire with a wire versus the 9-to-1 unun. And to look at it, you see where the resonance point is. It's interesting that it was not in any ham band for a particular length. So I took a carbon fiber pole, one that has a bottom that unscrews. Many of them do, and you can see there. Drilled a hole, made a bolt and nut mount point attachment, made a jumper cable. This is an LDG 9-to-1 unun, and put a C clamp on it that would clamp onto this rod. You can see here's the entire antenna. It's a random wire vertical. Faraday cloth for the counterpoise, the 9-to-1, and here's our friend, the Super C clamp. This is light enough you could clamp it to something, balcony or something else. Now let's look at it. Here is my back patio. You'll see I'm using this on a grill. It's simply a brace. I later put a rubber tip on this if I wanted to put it right on the Faraday cloth. And you'll see here in my backyard, you can see the sun shining off the copper. And I'll show you in just a moment how I put that on. Let me do that. You'll see each section. I took this apart. I put copper tape on each section. I folded it over so when you pull the thing out, copper meets copper, and you have a pretty good connection. You have to line them up. You have to make sure they're lined up as you see here. Now, I took a measurement here from the low edge of the band to the high and what the minimum SWR was. And so you'll see that as many random wire antennas will with a tuner, that you can get it to match fairly well and sort of broad relative to the particular band. Now, you'll see that on 17 meters, it was above and below, just a little bit, wiggled above and below. So I estimated about 50 kilohertz of bandwidth at less than 2.0 SWR. All All right. This was an odd day. I'm not making excuses, but nothing on 40 meters that particular day. This was at midday with a whisper beacon, 2/10 of a watt. Didn't do much there, but on 20, late morning, hit West Africa, 15, hit the East Coast, and late afternoon, and hit the West Coast on 10 meters mid afternoon. Kind of odd there on that one, but nevertheless, it got out with 2/10 of a watt. And my friend Scott, K0MD, a cardiologist up at Mayo Clinic, is a well-known contester ham. I built this for him. He travels to Jacksonville, Florida, at their campus there, the Mayo Clinic, as well as Scottsdale, Arizona. He has an ICOM 705, operates a lot of CW. And you can see this is just a short bag by Benro. I bought it on eBay. I believe it was $15 plus shipping. Everything will go in this particular bag. And I've got a little RG 316 coax with ferrite bead choke on it for a random wire. And there you go. Very short, less than 2 feet long, packs down, easy to carry. All right, let me close with this. Now we all know antennas are very important. New hams tend to want to buy that shiny rig. As my friend Martin Butler says, when he worked for one of the well-known ham dealers in the UK, he'd say, pick the one that looks the nicest to you. And I echo very quickly, it doesn't matter which is your first radio because it won't be the last. So we tend to focus on rigs, but we all know that antennas are what scores championships. Now, experimenting can be a lot of satisfaction, and it's delightful when we build something and they work. I find getting them optimized after you get them to work is a greater joy. I hope these are some inspiration to you and that you come up with your own innovations, and let me know how you improved on any of these. And happy to share it with you. Now, I've got one more thing I'm working on the bench, and that's a 2-element Yagi, monoband Yagi, 20, 15, 10, and 6. These 17-foot whips and smaller are ubiquitous. Here's some typical plumbing here with a T bracket from a PVC stock using the couplers, and I'm working on a particular match for this to get it up to 50 ohms. I haven't been able to work on it lately, but I'll be back on this. And a portable rotator will be very, very useful for this as well. So hopefully you'll see something on this at some point in the not too distant future with some small Yagis that we could not only have efficient ground plane verticals and others, but we could get a small Yagi with a homebrew rotator. We know which way it's pointing, and we'll see where our signal can go. So thank you for listening. Over here in the States, the Walgreens pharmacy has a program to prevent child poverty, and they sell you a red rubber nose. So I always encourage people to make fun of themselves by wearing a red nose. Okay, I'm happy to entertain questions. Now, look, Nick, send a note out to everybody and wake them up because I probably put some to sleep.
Frank, I genuinely do not think a single person slept through any of that. It was superb. On YouTube, by the way, Tim G5TM that you referenced in your talk there has been watching us live on YouTube. So good evening, Tim. And Tim makes a comment that Dick's website shows how to use the off-center fed vertical using one radiator and 2 sets of radials to get on 2 bands. And I said to Tim that your talk has been superb, but it's the construction ideas that make it brilliant. And Tim's just put, he agrees.
Well, so, Tim is very kind, and Tim is absolutely correct. There's a lot more than I showed you on Dick Reed's website. It was just that one little focus snippet. So he's got a great resource, and Tim himself is a great resource, and I've learned much from him. And he likes to read the textbooks, but also go out in the field and experiment. And so I've learned much from Tim.
Yeah, brilliant. Let me just take the slide off, and then we've just got the meeting room open to us. Frank, just before we throw it open, Ken, G4VZI, VZV, and myself were on the phone this morning, weren't we, Ken, for quite a long time, best part of an hour, talking about exactly what you were talking about tonight. Building an antenna that could work as a multi-band vertical antenna, but putting it up at the upper mast, 30-foot high, and how you would construct radials and measure it, and so on and so forth. So we were literally chatting about all these things this morning on the phone, as we do, about exactly what you were talking about there. And I'm absolutely certain we've got people in the room here who are all busting to make a comment and ask a question. So I'm not going to say any more myself at this stage. I'm just going to chuck it open now to the floor and see who wants to go first. And if everyone's shy, we'll get Ken to go first. So who wants to chip in first? Go on, Ken.
Okay, fantastic, Frank. That's what I can say. Fantastic.
Thank you.
Can I make an antenna that will beat any of them? Yes, but that's using a ground tuning unit by Saltwater. But that's a different thing.
Well, let me interject. Let me interject this. Before Martin shut his company down, I tried very, very, very hard to get him to make an automatic ground tuning unit that would send you do a tune signal. It sensed the band there, and it optimized your ground. Of course, he decided in the 80s to do it. So brilliant idea. I think you're spot on. That's another area we need to work.
Right. Well, just a few comments. Firstly, I knew Jim on the air, many QSOs with him, the W6LG, I think the call sign is, and he even made a video of me doing this work with a ground tuning unit, which is, I believe, still on YouTube. You mentioned the different coils right at the beginning. I do have one of those, what they call a big stick coil. Yeah. It's for the MFJ antenna, and it's rated at 1 kilowatt, which is fantastic. Airspace coil. I'm looking at the different screens. If I'm not looking at you, that's because I'm looking at the biggest screen, and the camera's down here. But when I was talking to Nick today, I mentioned about using one of those coils with a 17-foot width. And I think that could give fantastic multi-band operation. There's no doubt about that.
Ken, that was the big stick antenna. That Martin first came out with the big ear, which looked like the rabbit ears of yore. And I pushed him personally to come out with that. And he later said it sold 10 to 1 over the big ear. So you're spot on.
You mentioned rotators, and the one that you showed on screen, I've got 2 of them. They're not battery operated for portable. I've got the high gain version with the remote control. Off-center fed, oh, that's wrong. Off-center type rotator. Mine is holding up, get ready for this one, a quad antenna, and a 20-meter band quad. And they're fantastic rotators.
Yes. I think pioneered by HCJB, and their engineer's last name was Moore down there, because he got arcing in the moist air.
Correct. Yeah. Mike, this is what I would say to all that are listening at the moment. Why are so many Russian stations putting out fantastic signals from the top of their apartments? And a lot of them use ground plane antennas. I'm focusing on the ground plane. I think that statement speaks volumes. Now, I was talking to Nick this morning about putting one on a tower It's not a very high tower. It would only go to maximum height 30 foot, 31 feet. And I think the scope, and I like experimenting. I think it'd be fantastic. There is an antenna that is on the market, commercially made, called the Grazioli. It's from Italy, and that is a ground plane with fixed radials. I think they call it the Grazioli Mike Victor 6, MV6. But the difference is you could spend £80 yourself making, or $80 making one, against $600 to buy one.
Yeah.
And I know K4OGO, Walt, and Walter has put a video up quite recently, actually, of doing by the sea a ground plane using exactly what you said with the 17-foot radials. The only thing is, it toppled. It was leaning over because it's bloody heavy.
And he has a lot of wind being near the ocean. You know, you're going that's the one. Some of you probably have done repeater work. I've been on top of one of the hospitals here in Jackson, which is on the highest point in the city of Jackson, Mississippi. And the wind, we had to quit buying the inexpensive antennas and spend some money and get those made of steel, because the aluminum just got beat to death in a year's time.
Yeah, I think those 17-foot whips have got the limitations, especially if you're going to start putting them horizontal or even at 45 degrees.
And you saw the pictures, how it got unwieldy, which you can see there was a practical reason I got interested in the OCF, because it allows you to shorten those, and even to where I might even be able to use the 2.5 meter shorter whips on the radials with the longer vertical. It stands on itself better than it goes outward parallel. So.
And final comment, again referring to Salty Walt, he made an antenna, which I can't remember the name of it, but it was an off-center fed vertical antenna. I think it was focused mainly for the 20-meter band. I can't remember. Oh, I do. It's called the Coastal 20, and he's got a YouTube video. And again, when you mentioned the off-center fed, I've built it, made it. It only took me 20 minutes to make it, but that antenna worked with my G90 in my own garden, so there was no salt water around. Not that I needed one, because it was an off-center fed dipole, and I just thought, wow, this is very good. So if anybody wanted to go down the line of something very simple, the off-center fed Coastal 20, but everything that you mentioned there, just fantastic.
Thank you.
And
Walt has a second book. He has a second book coming out, and he may have some more of those in it. So.
Right. Well, and the other thing, the idea with the 1800, I was thinking about that recently. The only thing is, it becomes very much a bit like a magnetic loop, doesn't it? As you go further away from its resonant delta loop length frequency.
Yes.
But again, for simplicity, for portable work, I think it would be brilliant. And I've got 2 of those AT100s, and they work fantastic. You just have to charge them all.
When I prototype this, if you think about the geography of where I'm located here in Mississippi, it was literally mounted on the ground. It was sitting on the ground when I prototyped it. And I worked the Illinois QSO party. Everybody I called, I worked. I
know that, yeah.
And I just turned it broadside to that direction. So, it's fun balancing what you read in the textbooks versus what you experimentally see in the field and coming together. And Ken, you've got some terrific ideas, and thank you for your kind words.
Okay, if you're about and you're on the air from probably this week, well, from Sunday, probably for a month, I'll be operating by the salt lagoons. I may have even worked your call sign without looking it up, but I'll be operating from the salt lagoons again with my radio station on a sack trolley, of all things. So, okay, thanks, Frank. Brilliant.
Thank you.
Yeah, thank you, Ken. And Tim popped up again saying he thinks an auto ground tuning unit would be a game changer. I'm sure he's right.
I've
It's a
tried to
shame
get.
you didn't persuade Martin to build
Well,
it before he
it
shut up.
well it ran out of time, and I've been a consultant to him, and it was at a point where he wanted to be able to visit his family, and his brother moved from here to Houston, Texas, and they were very close. But in any case, I tried to get Mark Smith of Halibut Electronics out on the West Coast to get interested in such a device. And Mark's a good design engineer, but who knows? Maybe some energetic person will hear this and go to work on it. But I do think that would, as Tim said and as others said, Ken said, that would be a brilliant addition, and is currently a little bit of a gap in what we're doing for portable HF antennas. So.
Brilliant. Anyone else with a question or comment in the audience? We've had a number of people who've had to leave us already and just made comments about how much they've enjoyed it.
Well,
anyone else want to make a point? I mean, Frank, I'm going to say, I mean, a number of people in this room and in our club who I know are going to be catching this up on YouTube in the next few days have, like you, have made great use of AliExpress. I've got one of those bases that you talked about for exactly that, and I built myself a Delta loop using two of their whip antennas. Wind is definitely a factor. I mean, I built it with the thought of being able to take it up into the hills. So where I live, Frank, is about half a mile down the hill from where I took that picture behind me there. But I walk up a bit further, only 20-minute walk from where I live. I'm on top of a hill up in the Pennines here. And I thought this would be a fantastic spot to use that Delta loop from. The problem is, even when we haven't got any winds, we've got winds.
Yeah.
And I think those, when you've got those AliExpress poles or the MFJ ones completely extended, the chances are they would snap or get extremely bent in the wind. So that's the only thing that has held me back really from playing with that as a portable Delta loop antenna, because otherwise the idea is fantastic. One of our members, Lou G8KJJ, is not here tonight, but he got inspired with the Delta loop antenna and has built a number of monoband versions of them using either aluminium or using the solid plumber's pipe and running a wire inside that.
Right.
And he's had very, very great success working DX on those on 15 meters and 12 meters over the last 6 months, I know, since he put them up. So yeah, I mean, I think you've given so many ideas. Jeff, ON8NT.
Okay, very good evening to everyone, or very good afternoon to you in the States there. Frank, that was brilliant and very inspiring. And while you were talking, I was remembering a guy in our local radio club here in the 80s. He was a Sibir. He was a member of our club, but he was a Sibir. And he used a ground plane with one radio on a rotator. So he just rotated that, and he had excellent results with that. So he was living in Ghent, and he worked in Brussels, which is 50 kilometers away, and his wife just put the rotator and the ground plane into his direction, and even if he just left Brussels, they could communicate with each other. And if they went to the seaside, which is the other side, to Ostend or so, they just turned around the ground plane into the other direction. But he was also doing some digs. This was the time of the big solar flares in the 70s and 80s there, and he really made fabulous gigs here, even in FM. So that was just an idea which came up while you were talking and talking about ground planes and the 45% angle and so on. So great talk, Frank. Thank you very much.
Thank you. Thank you very much. And remember, sometimes our culture in this hobby, we're negative to CB. and there are some CBers that aren't serious, but there are some very serious ones. And I've seen CB operators build fantastic quad antennas that were just incredible.
He
Now, of
was
course,
one of them.
here at 27 megahertz, the size was amenable, I must say. But there's a lot of good work out there if we keep our eyes open, Jeff, as you say. And it can be amazing. That was an incredible sunspot cycle. I was in CB radio. I had a 5-element Yagi. I was maybe 16 years old or something. I had a 50-foot pole that was put in our yard with pegs, and I climbed it. And I had, I think I had a 500-watt amplifier, but I'm sure that was terribly illegal. But I used to talk to a guy whose CB handle was the Hangover Wolf in Medellin, Colombia, from Middle Georgia, almost every day at lunch. I mean, it was like clockwork. So, yeah, a good sunspot cycle makes even poor antennas great ones. But, yeah, you bring back some memories, Jeff. Thank you.
Yeah, thanks for that, Frank. Anyone else with a comment or a question to Frank? What I've done, by the way, and this is just particularly for one or two new people in the room tonight, I've popped the presentation into our WhatsApp group. So we've got a club WhatsApp group. So if there's anyone here online wants to join it, it's specifically aimed for discussion, particularly about antennas and portable operating and operations and activations. So I know, as Ken was saying earlier to Frank, he's going to be down in southern Spain in the salt lagoons from next weekend for several weeks. And what Ken does is to post his activations on the WhatsApp group, and people look out for Ken when he's transmitting and when he's working that fantastic DX into the Pacific that we might struggle with our wire antennas back home here. Ken is very, very happy for us to call in and to facilitate us making those QSOs. And a number of us have done that several times. But also he demonstrates the point about what you can do in the right location, of course, in the salt lagoons with a simple vertical antenna and the ground tuning unit. So he doesn't need to have wire radials floating around the ground, doesn't need a Faraday cloth anywhere. He's got the ground tuning unit doing the work for him.
Yeah.
But so I'm going to post it on the WhatsApp group. Anyone wants to join it that's not a member already, if you just drop me an email, g4iwo@btinternet.com, or the club email address on the website, I'll get back to you and provide you with the link to WhatsApp. I'll put up this talk that Frank's given tonight. A number of people have already contacted me to say, is it going to be on YouTube? It will be up there tomorrow on YouTube. And I'll also put a link to our club website where I'll put up the slides from Frank's talk as well, so that people can, in their own time, go and have a look at some of these things and look at the slides, because you provided. I mean, I started to make notes, Frank. I realised I didn't really need to do it because your slides have got quite a lot of text on them that put those comments in. But lots and lots of brilliant ideas. I bought myself a photographer's tripod to do exactly what you were talking about. I haven't got around to it yet, but I did discover that AliExpress were now producing these 1 foot length extensions with the M10 connectors on both ends. Right. And I thought exactly the same as you. The best way to do that would enable you to bring if you're putting in a coil to get resonance on 40 meters, for example, on a 16-foot whip, it will be considerably improved if you can put the coil a bit further up.
Right.
So I was thinking exactly that. Can I use that photographer's tripod with a couple of those extenders, and then from the extender put the coil on, and then put a whip above it? Is that going to get me some better performance? And you answered the question. I know it is.
Well, recently we've had our first libraries on the air. As you may know, I've got a program promoting bringing ham radio on the libraries, and one local library has a great awning in the back and a garden, beautiful garden in place you can put up antenna. And I used that Eiffel antenna, and frankly, I was surprised at how well it worked, both 40 and 20, and it is easy to put up, and like I said, easy to put up and take down, and worked well enough to make it worth your time. So good luck with that.
Yeah, we've got in a couple of weeks' time, Frank. We've got Jim N4KCT, who's he published an article in QST that just made me smile with pleasure about building an HF beam antenna or a VHF beam antenna into a sheet, and hanging that. I've had a chat with him as well off air, just between the two of us, and he's got some brilliant ideas. So simple, absolutely simple.
Yeah.
I mean, the starting point for him, what he's hard. So I'm just kind of giving that for people on here tonight. 2 weeks time, he's going to be back here, and I know that starting point for him, he's produced a little video on it, which is brilliant. He got himself a little hut up in the mountain somewhere, no electricity, no power, nothing, and that's his little escape in the world. But while he was up there, he took his 2-meter handy, and he kind of listened out and couldn't hear a thing. And he knew there was a repeater 15 miles away, couldn't get into the repeater. So he thought, well, I need to put up a beam really, but am I gonna do that and leave a beam here? And he decided not. So he made one. He sewed one, a 5-element 2-meter beam, vertical beam, into essentially the size of a flag. A sheet,
Right.
that kind of size. And he said, I'm just going to put the beam up, and he attached it to the roof of the extension of his hut, and the cable was out the bottom, plugged in his 2-meter transceiver, and immediately he got into the repeater 15 miles away that was completely dead, and that led him to then think about, could I do something similar for HF, which would obviously be a bigger sheet, but and horizontal rather than vertical. And that's what he's going to be talking about. So, Frank, I love the ideas, the construction ideas that you put there, and they answered one or two questions that Ken and I were debating this morning. It's those tricky things, isn't it, between getting the adapter for the 3/8 that we use for the whip construction to the M10 that the Chinese are using for their whips. It's those little things that make all the difference to what we're playing with here.
Yes, indeed. I look forward to seeing that talk, and I want to thank you again for having me. I feel a kinship with this particular group, and I appreciate that. I'm always envious as a former radio personality of Jeff's voice. I'd love to have his voice. He's got the ideal radio broadcast voice, Jeff.
And actually, we've got Jeff because being a wonderful multi-language speaking person living in Belgium, we're going to have we had Mike and Adriana here who are from northern Germany, and they gave us a talk about learning a bit of the German language and using German in QSOs. And we had some people really inspired by their talk who've come back to us a few times to say, oh, we followed it, it was brilliant. So Jeff is going to come back, and Ken as well, because Ken speaks a very good Spanish as well from all the time we spent out in Spain. And they're going to give a talk about using the French and Spanish language, and this is next month, in QSOs, and just giving a few ideas of of words and constructions and so on that people can use. So yeah, we just Frank, what we love in this club is playing with things, whether it's ideas like that, whether it's antennas, whether it's other bits of construction, um, sharing ideas with each other. That's what makes it all fun, doesn't it?
Well,
Makes it great fun.
I've helped some clubs that have gone maybe a little stale and things. I've helped them rebuild, and one on the south side of Jackson, um, they did not approve my slogan I proposed for them, but the president said, "Well, you keep the website, so just put it on there anyway." And it was hashtag We Do Stuff. Now they brag on that, and I said, if you keep that as your mantra, we do stuff. The stuff can vary according to interest, but as long as you're doing stuff, and clearly Pennine is doing that. So thank you once again for having me back.
Yeah, Frank, can we show our appreciation to Frank, everyone, in the normal way? Thank you very much, Frank. It was superb. Just before you go as well, Frank, you gave your talk right at the beginning about getting into amateur radio through that VHF transistor radio. That was exactly, and you and I are of the same vintage. That was exactly my path as well. I was 10 or 11. For Christmas, I was given one of these newfangled transistor radios with an aluminium pulled out whip on it. And the first thing I did, as I did with anything, was I took it to bits. And I was playing with the coil on the, it had the little ferrite, the circular ferrite in the middle. And I was playing with that. And suddenly, I wasn't on medium wave. I'd just gone up a little bit. And I didn't know this at the time. And I could hear these guys talking. And it was, what I discovered was it was 160 meters. It was on top band. And in those days, it was mainly AM. So it was local guys on amateur radio using top band. And having done it, I came rushing downstairs to my dad and said, I've just taken that radio to bits. It's fantastic. And he said, what's made it so good? He said, I said, I've just been listening to these people talking on it about things to do with radio. And he said, show me. So I showed him. And he said, how did you do that? So I explained it. And he said, do you think it's something you'd be interested in? And I said, I would. And I discovered then, I didn't know till that point, that my dad had got into amateur radio before the Second World War. So he took me up to his dad's house, went up in the loft and came down with all this kit. Anyway, that got him inspired to get his amateur radio license, which he'd never taken up after the war, and get back into amateur radio. And that was my path into radio as well. So it's funny how something like a transistor radio was a spark to getting into this hobby.
Yes, indeed. Yes, indeed.
Brilliant. Thank you very much, Frank. Great to see you.
Take care.
Cheers. And a good night to all our viewers on YouTube as well, because I'll break the link on YouTube. And a good night, of course, to those that are watching this on the video in the coming days.